All right, everybody. So, welcome to our next build series. So, we are going to be building our L3 certification rocket, and there are some parts of that laying out here. It's going to probably be like a 10-part series, and so welcome to part one. We've got a bit to get through. The beginning part isn't crazy exciting, but I'll have some neat little info in there, and if you enjoy this sort of thing, happy to have you tag along with us. So the first thing that we had to do, we did it yesterday actually, and I'll show some clips of that here in a moment, but we washed all these pieces of fiberglass, the tubing, so that you just get a lot of the machining dust and other dirt off, some of the demolding and stuff like that off of there. Again, maybe doesn't need to happen, but it's just sort of something we do at this point. Next, what I'm going to do is I'm going to do an awful lot of surface preparation. So the funny thing about working on fiberglass for rockets is that I use heavy duty epoxy for that, and I'll showcase a lot more of that later when we get to those steps. But this stuff is smooth, meaning that you're really banking on your surface preparation and to be a key part of whether or not the epoxy is really going to hold when everything is up to pressure. And by the time you're doing an L3 rocket M and higher motors, there's a lot of pressure that gets put on these things. So some of the stuff that I've learned about surface preparation that has paid off on some of our smaller rockets, like over there, is going to be the stuff that I would attribute to, I'm going to shout out to rocket vlogs and things like BPS Space, and then also some of the mentors here at the Southern Arizona Rocketry Association. Some of the stuff I do now is the kind of stuff that they do in aerospace tech, and so again, certainly not as fancy or smart as those guys out there, but some of the same principles apply. So we're obviously going to hit it with sanding at the start. We're going to go as low as 80 and 60 grit to make some rough surfaces in these things. And then from the chemical side of getting contaminants out of the particles on the surfaces, I'm going to hit it with acetone wash, but in no singular spot more than 10 seconds. After that, you can start to degrade unnecessarily some of the wound fiberglass tubing here and the epoxy that's on it, just inlaid in it. So I want to rough it up, but I don't want to deform it. And then after that, I go over it again with a wipe of isopropyl alcohol. I tend to prefer 90% just because bigger numbers, but 70% is fine. So I hear. Anyway, and then of course, if you don't get to your epoxy right away, generally speaking, I end up having to go over it a little bit again with some of that isopropyl by the time I do that, just because air contaminants are going to get back into some of those surfaces. But that's the short and fast version of the surface prep. And today, the rest of the video is going to be you tagging along with me for what I think is personally the most arduous part of this entire thing, sanding. And anything about sanding fiberglass, you're going to see the PPE that I put on. Because God knows you don't want all that stuff in your lungs, your hair, your clothes, your eyes, the whole bit. So I got goggles, respirator, and not really necessary probably, but I got a kid in the house, a little kid, and helps me with my peace of mind to wear one of these like paint suits. It's hot in Arizona, so it's gonna be fun. But anyway, this prevents more and more of the dust just getting in my clothes and stuff like that. So dusting up fiberglass, you don't usually want glass in your lungs, but that's why you protect yourself. Join us along the way and have fun. Thanks. All right, well, just about an hour and 45 minutes later of sanding, and it's hot. But we're done with the sanding part, at least for now. So next up is I'm gonna do the wash down of these things. But you can see I'm gonna walk us through the parts that are sanded and just point out some things along the way. All right, you can see we've got fin number 1, 2, and 3. All right, you can see any part in which there's gonna be adhesion to any of the 6 fillets that are gonna be on there. There's gonna be one on the very bottom connected to the motor tube. Then there's gonna be another one connected to the ceiling of the body tube. And then there's gonna be another one on the outside connected to the top, the outside of the body tube, okay? For each one on each side. So 1, 2, 3, 1, 2, 3, which gives us a total of 18 fillets across all 3 fins. Hopefully that's strong enough. All right, so those are all sanded and ready to go. We have our centering rings, 1, 2, and 3. And so I gotta make sure that those are nice and well sanded, because a lot of the holding everything together with the push of the motor is gonna be dependent on those and them connecting to the motor tube and the inside of the back or aft body tube. Okay. All right, and here we have bulk plates, okay? And so one of these is for the inside of the nose cone where an eye bolt is gonna come down from, and then this one you can see is beveled, okay? And that goes on the top inside or bottom inside of the AV or electronics bay, which is this tube over here, okay? This will fit inside both the bottom and top outer body tubes. And this is the switch band that will go on the outside around it, about in the middle, okay? When we get there, you'll see all that. Which is why we had to do sanding and scratches on the inside of this, not just to smooth it out on the outside. Overall, everybody, I did a smoothing on the outside so that there's good paint adhesion eventually, but all the key parts for epoxy adhesion were given a lot of attention, okay, in terms of scratching up. The AV bay doesn't really need to be scratched on the inside, so I didn't sand it on the inside, but I smoothed out the edges and made sure the outside's good to go. This is the upper body tube, or the payload bay, okay? That doesn't have a whole lot of really important things that have to adhere epoxy-wise to that at all, almost nothing, so I just gave that a nice outside once-over and smoothed the edges. This here is the coupler for the nose cone, okay? So I scratched the heck out of the inside of that to make sure that our bulk plate fits nicely and secures inside, and then also the outside of it, because it goes up inside our nose cone here. So for that one, I just roughed up the outside for paint. And then on the inside, I did a lot of work just to make sure that the inside of that and the outside of this epoxy well together, okay? This is our motor tube, one of the most essential parts of all this. So didn't do any scratching on the inside, don't need to, it just needs to be able to smoothly slide in and out the motors. That should be fine. The outside of this, okay? It's hard to see through all the dust, but I scratched up the whole thing an awful lot, but I gave particular cross threading attention to specific places where those centering rings are going to be placed and whatnot. Okay. Now, our body tube, the most arduous part of the whole process. You can see this line I just kind of drew here with my finger to mark where on the inside I was gonna need to scratch up, okay? And you can almost kind of see that discoloration where I scratched in and around where that upper centering ring is gonna go. And then lower, much lower down, hard to see from here, at the top of those fin slots, you'll see I did an awful lot of scratching at the top and bottom of the fin slots, and on around the fin slots on the inside and outside, just to make sure that the fins and the fillets stick to it, and where their centering rings are, middle and bottom, fit well into it and stay. All right, so that's everything from a sanding perspective at this point, okay? And now I'm gonna wash them down with acetone, okay? And then isopropyl alcohol. All right. And we'll show you after what they look like real quick. But just so everyone remembers, the acetone, I wet a shop cloth and then I wipe down, and I don't stay any longer than 10 seconds in a particular spot, and I move on, okay? And then after that, I once over everything with a shop cloth and the isopropyl alcohol, and then we're done. So now, after we've cleaned everything, I'll let you know that what I decided to do today was, instead of acetone wash and then use the isopropyl alcohol, today what I did was I just did an initial wipe over to get all the dust off with the isopropyl alcohol. I decided that I'd rather do the acetone wash and then isopropyl again very shortly before I do any of the actual epoxy work on any of the parts that I'm actually using at that moment. Okay, so for now, what I'll show you, the last thing I'll show you for this first part of the series is I'll show you some of the lines and marks that I've made already for where I'm going to be doing some drilling and things like that. And it wasn't on camera, but I did do some sanding of the edges and the inner parts of these rings just to make sure that they fit really well and are going to move just fine when I'm actually doing the epoxy work. So thank you, everybody. This is going to be the last portion of this first part of the series. Hope you join us for the rest. Thank you. This is for the forwardmost centering ring, and you can see where this is going to fit down over the motor tube. It's going to hang about a ½ inch below the top of that tube, and you can see I put marks here for where I'm going to drill holes for the eye bolts. Okay. This is the center, the middle centering ring. It's just, smoothed out on the inside, on the outside, so I can pretty nicely just slide it into the middle of that tube when the tube is already inside the body. This is the aftmost, or the rearmost one, and you can see here where I've done what I need to do with this thing. This is the motor retainer, okay, and it goes over like this. Now there's actually a little bit of a difference in the width of this versus the width of that, and it accounts for the actual motor tube distance. So what I had to do was I had to actually fit this on the motor tube, then fit this on top, get it completely centered, tape it down, and then what I did was I went around and I drew a line on the outside, and I put little dots and pin marks where I need to actually drill the holes for that. Later on, I'll walk us through the drilling, and I have to actually tap these holes too for screws before we add any epoxy. Now for this section too, I'll go over it more later, but there's gonna be JB Weld is gonna be our epoxy for that, just because this has a temperature rating far above what I need for where, all that fire blast is really gonna be hitting. The rest of it, we're going to use air epoxy, which is pretty darn good, and Total Boat Thixo, which will work really well. But this piece in particular, especially because it's attached to a metal component that's hitting the actual flame, has to be the most heat resistant. Normal epoxy usually just won't do for that, not at this level. All right, this is the bulk plate for inside the nose cone. This has been all smoothed out. It fits inside perfectly of the coupler. And then this is the bulkhead for the AV bay, one of the two. And I have marked the actual spaces where I need to drill holes. So you can see, that's a conversation for later, but I custom made this out of a couple different pieces of wood from Lock Precision, and cut down these threaded rods. And this is gonna be where those fit in here. You'll notice I only have one and I need two, okay? When the kit was sent to me, or all the pieces were sent to me, it was missing one. And so they apologized and they're sending one out to me now. So all is good. I'll work on it when it gets here in a few days.